This video class is for your SKM University, DUMKA, okay, semester 3, measure 4, okay, for measure 4. So I am starting with unit 1 as exam is approaching. So I will start with unit 1, okay, and I will try to complete before your end semester exam, okay, for semester 3, correct. So here this is Dr. Gopinath Gorai. Okay, Assistant Professor, St. Xavier's College, Maharo. I'm giving you this free lecture as well as notes also I'm giving over here. So please utilize it. What I'll give the concepts as well as I'll give the notes which will be helping for you. Okay, so wherever you are studying, okay, but still you need these notes and this concept. Okay, so no need to pay anything for study. So that's the unit 1 we are starting. It's a basic organic chemistry. Okay, basic organic chemistry. Under this, we will start first is your, according to your syllabus, it is organic compounds, classification and nomenclature, okay? So, what is basic organic chemistry? Just see, we know that carbon has a unique property, right? Carbon has a unique property, okay, which we call it, or we can say that it is a catenation, okay? Catenation, correct? That is, it means, what does it means? It is like, it can combine, okay? It can combine with one another to form rather long chains and rings of different size, okay, of different size. It means we can say it is go till infinite. If it is carbon carbon bond, suppose this carbon I am taking and this catenation for carbon, the catenation is 4. So what is happening here? Either you go this side or you go this side, or this side. Again, if it is carbon, again the catenation it will start. Okay, so here also if it is carbon, it will continue. It will continue. See, it will continue. Correct. Likewise, so see everywhere it is 4-4 bond. It is making 4-4 bond. So that is the catenation. Correct. So it is continuing. And for carbon, the catenation number is 4. Correct. So now we'll see the organic compound. Okay. I hope you have written this. So organic compound, how we are going to classify this organic compound? Okay. So here is the organic compound. We can classify this in two broad category. One will be your open chain. Okay, open chain, or we call it acyclic. Okay, which is aliphatic compound. Okay, example your alkane. There are many, but we are taking only one example over here. So alkane. Second type of classification will be if one is open chain, another one will be your closed chain. Correct? Another will be your closed chain or cyclic. So in this case, again, it can be further divided by this. It will stop over here only. Acyclic aliphatic compound, correct? But here the cyclic, again, it will be classified based on two. One will be your carbocyclic, or we call it homocyclic. Okay. Another one is your heterocyclic. Now try to understand. This is open chain. It will be like this. This is closed chain. Wherever it will go, and the end will be connected. If this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. So last carbon will connected with the first carbon. So it is cyclic or closed chain, correct? Here 1, 2, 3, 4. First carbon will not connect to the fourth carbon. So this is open chain, correct? Now carbocyclic. What does it means carbocyclic? Carbocyclic means all the member present over here in this cyclic compound are carbon. Okay, all the member is present over here in the cyclic compounds are carbon. That's why carbocyclic. Homocyclic means homo means same. It means same elements are there in this entire cycle. Okay, the backbone is formed with the same type of element. Correct? All are carbon. CH2, 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 CH2. So this will be your homocyclic or carbocyclic we say. Even this is also example of homocyclic or carbocyclic. This is aromatic because further we are going to classify this. Okay. So this is also your carbocyclic or homocyclic. But what does heterocyclic says? Heterocyclic it means other than carbon. Okay. Other than carbon. So here also we can classify it like heterocycle. It is like monocyclic. Okay. And your polycyclic. So in monocyclic, example will be your pyrrole. Okay, pyrrole. See, in this ring, what is happening? This is the heteroatom. See, here carbon, 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 one nitrogen it came. So minimum one. Okay, if other than carbon, if minimum one atom is present, which is other than carbon, then that cycle we call it heterocycle. Hetero means other. Okay, different. So hetero means other than carbon. So this is the other than carbon. So this is called heterocyclic. If suppose this is also a carbon, then it will come under this carbocyclic or homocyclic. Correct? This is monocyclic because only one cycle is there. Pyrrole is there, furan is there, thiophene is there, pyridine is there. Correct? So these are all monocyclic. What about polycyclic? Polycyclic means two ring will be there. More than, or we can say more than one ring. So suppose this one, this is, what does it name? It is your, here I will put, sorry, here I will put double bond. So here, see, this is indole. Okay, so your indole, isoquinoline, quinoline. So these all are your polycyclic. Okay, and see, one atom is this nitrogen is other than carbon, correct? So that's why we say that it is heterocyclic ring. Likewise, I'm just removing these two already. I thought, or maybe you have understood what is carbocyclic and homocyclic. Now I have to classify this further. Okay, so here it will be your aliphatic cyclic, aliphatic cycle. Okay, or we call cyclic, and then or alicyclic also we call it. Okay, example, this is what does it name? Cyclobutane. Correct. Second will be your aromatic. Okay, aromatic. So in that aromatic again we have to classify. See here in this alicyclic, cyclobutane, cyclopentane, cyclohexane. Okay, everything will come. Now here aromatic also one monocyclic. Okay, monocyclic benzene. Now here your polycyclic. Here it will be your naphthalene, anthracene, phenanthrene. Okay, all will come. So this is naphthalene, this is benzene, this is naphthalene. Correct? So this is the classification of organic compound. Okay, now we directly move to the nomenclature. Okay, directly we are moving towards nomenclature. So we'll see how nomenclature is work. Okay, in nomenclature there are many types like trivial system of naming, common system of naming, but what you need over here, you need only IUPAC nomenclature. Okay, IUPAC nomenclature you need. Okay, how the IUPAC name, but still, this IUPAC nomenclature is very much famous in your aliphatic compound only. Okay, aliphatic compound only it is very much famous, but till now whatever you are getting for aromatic they are use common name only. Okay. They use common name only. Here also you can write IUPAC name, but in examination directly they will ask what is toluene. Okay, they will not ask you what 1-methyl benzene. Okay, they will ask you what is toluene. Okay, what is cresol. Okay, what is catechol. What is aniline. Like that they will ask. So the common name will be very much famous in aromatic compound. But in aliphatic, it is like IUPAC, because the IUPAC name is quite easy than the common name, because common name you have to mug it up, but IUPAC no need to mug it up. It is like based on whatever structure it has given, follow some ICP rule, and then you name it. Okay, frame the name and just say the name. So first will be your, we'll start with the rules. Okay, because as I told you that common name and trivial name now it is not in popular, and that is also not that not is those type of nomenclature it is not asking in your examination, correct? So this IUPAC nomenclature we call it systematic names. Okay, so that is IUPAC. Okay, so in 1892, okay, in 1892 in Geneva, okay, where in Geneva, what happened? One like how the seminar and conference is happening, like that one seminar type of uh, seminar type of call they have attended, and in that they were discussing that how the compound should be given name, and based on that they have passed one bill that we call the IUPAC. Okay, so what does IUPAC stand? This is International Union. Okay, International Union of Pure and Applied Chemistry. Okay, so here to do with this, we have some sort of basic formula. Okay, so that formula we'll write first. Before that, okay, first we'll write the formula and then we'll try to understand each and one constituent of this formula. Okay, so I'm just starting with your initial, that is word root. Then it will follow your primary suffix. Then it will follow your secondary suffix. Correct? This side it will go with your primary prefix, and then it will go with your secondary prefix. Correct? Now we have to understand each and one, like what is secondary prefix, what is primary prefix, what is word root, what is primary suffix, and what is secondary suffix. Then only you can name the whatever the incoming, like whatever structure it has given in your examination or in your day-to-day life, to give IUPAC name to them. This sort of formula you should practice. Okay, this formula you need to be practice. So how you are going to practice this formula? See, from today onwards, whatever name they will ask you, suppose this is CH3, CH2, CH3. If they are asking what is the name, you know that this is propane. But what you do, you just write first this formula. According to word root you put, according to primary suffix you put, according to secondary suffix you put, according to primary prefix and secondary prefix. If suppose secondary suffix is not there, you put 0. If primary prefix is not there, you put 0. If secondary prefix is not there, you put 0. Likewise, you do it, okay? And then finally, you write the name equal to propane. Suppose this example I am taking, this is having 3 carbons. So 3 carbon we are calling word root prop. Plus, what is primary suffix? Here, all the carbon is having carbon-carbon single bond. If it is single bond, then we are writing A and E, okay? Then what about secondary suffix? Is there any functional group? No, right? So we'll put 0. Is there the molecule is cyclic, means the first carbon is attached to the last carbon? No. So here also it will be 0. Is there any secondary prefix? Secondary prefix means if more than one functional group is attached, then the less prior group will be your secondary prefix, or bromo, nitro, it will be in the secondary prefix. Okay, so those items are not over here, so just we will put simply 0. So now equal to, just add it, prop, and remove this plus, and you just write directly A and E, propane. Okay, there should not be any space, so propane. So this name is propane. So like that we are naming the we are using this formula for naming purpose. Okay, so from today onwards, whatever nomenclature you are getting, first you write this formula and then try to name this uh, like the propane or butane or pentane. Okay, but in your examination no need to write this formula, directly you can write the propane. Okay, but in rough page you do that. See, if you are doing this, then error will be very less, right? So now to go with the rule, first rule is like we have to understand the word root. What is the word root, that we will understand? Okay, so first point we are taking word root. Okay, word root or root word. This is the root word. We have to find always the longest chain. We have to, that rule also we will discuss. The longest chain we have to find, and in that longest chain, what we have to do, we have to just see how many carbons are there. Okay, if it is only one carbon is there, we call it meth. If two carbon is there, we call it eth. If three carbon is there, we call it prop. If four carbon is there, we call it but. See, this is 1, 2, 3 carbon is there. That's why we have taken word root prop over here, correct? Now, if it is 5 carbon is there, we call it pent. Every 6 carbon is there, we call it hex. Every 7 carbon is there, we call it hept. 8 carbon, we call it oct. Like that it will go, okay? So this is word root. Okay. Likewise, primary suffix. Okay, in primary suffix, what we have to see for primary suffix, whether if only one carbon is there, if only one carbon is there, we call it ane. If carbon carbon single bond are there, all carbon carbon, like, see here 1, 2, 3 carbon is there, so this condition is invalid. Now see carbon carbon, here single bond, here also carbon carbon single bond, so carbon carbon single bond also we are putting ane. If carbon carbon double bond is there, any one of the carbon carbon double bond if it is present, we will write ene. If carbon carbon triple bond is there, we will write it yne. Okay, this is your primary suffix I am telling. Got it? So this much only we should know right now, because the rule we are going to say, we have to select the longest chain, okay, and then parent chain, then from which side we should numbering, everything we have to learn it. Okay, so first it is word root, then is primary suffix. These two is the basic requirement to name any of the molecules. Suppose you want to name for this compound, this is methane, right? How you are going to name? Here what is the word root? Only one carbon is there, right? One carbon, so it is meth. See, one carbon, so there not be any carbon carbon single bond, double bond or triple bond, so only one carbon, so we call it ane. Finally we'll write ane. So this is methane. So that's why this word root and primary suffix, okay, these two is very much required to name a minimum, like whatever, like any organic compound. If you want to name simpler organic compound, if you want to name, you have to use word root and primary suffix. These two you need, then only you can name the organic compound. Correct? Got it? So likewise, we'll see your secondary suffix. Okay, what is secondary suffix? Secondary suffix is nothing but your functional group. Okay, functional group present over here. Whatever functional group is there, that we call secondary suffix. Okay, so we'll just write to indicate. Okay, to indicate functional group present in a compound. It is added after dropping terminal E. Okay, terminal E of the primary suffix. So what we are doing? So to indicate this functional group, what we will do? We just like methane. If suppose methanol is there, CH3OH. So what we are going to write? We know that one carbon is there, so we'll write meth. We know that carbon, only one carbon, so ane. Now to write this alcohol, this is alcohol, okay, hydroxyl group. So for that, it will be, if it is secondary suffix, then we will write this OL. So to write this OL, we'll just remove this E and we'll put OL. So the name will be like methanol. Methanol. Okay, methanol. Al will be for aldehyde, correct? So methanol. So few functional group I'll just write, not all. Okay, but as you practice, you will come to know. So this is the functional group. Okay, so if it is alcohol, is like that. If functional group is there, so what you will write? You will write OL. Correct? If suppose aldehyde group is there, you have to identify the functional group. This is aldehydic group. If aldehyde group is there, you will write Al. Means the terminal E you have to drop it and you have to write OL, Al. Okay. If it is ketone, like this flank, if it is present, this carbonyl compound, both the side minimum 1 carbon, then it will be O and E. Correct? If it is your carboxylic acid, then you are going to write oic acid. Correct? If it is your esteric group, O, and then this side maybe any methyl, ethyl, propyl, any alkyl group. So how you are going to write? This is oic acid, okay? Oic, O-I-C, oic acid. Here you have to write O8. It means this side name first, ethyl or alkyl, and then this name will be your O8. Okay. So now if this type of flank is there, okay, so we call it oil chloride. Okay. So this is for functional group, and functional group is come under secondary suffix. Okay, and what is primary prefix? That also we'll discuss over here. Primary prefix. So if the compound, if your given compound is cyclic, then only it will work. Then add it cyclo. Okay, if it is cyclic, then add cyclo. Suppose this is 1, 2, 3, 4. 4 carbon is there, so but. All are single bond, A and E, butane. Now see, first carbon, this is 1, 2, 3, 4. First carbon is attached with 4 carbons, so it is looking like cyclic. So we'll just add cyclo. Where instead of primary prefix, word root and primary suffix. So in primary prefix, we put this word cyclo. If it is not cyclic, then we'll not put anything. Okay. So this is cyclobutane. So that is the role of primary prefix, this much only, correct? Now, correct, we'll go to secondary prefix. Okay. Secondary prefix. When we are applying, this is also for functional group only. But when do I apply this? When there are more than one functional group is present, more than one functional group, and in that one will be having higher priority and one will be having lower priority. The higher priority functional will go for your secondary suffix, and the lower priority functional functional group will come under your secondary prefix. Okay, so we'll just write to indicate. Okay, to indicate lower priority functional group and the substitute. Okay, and the substitutes, it is added before the primary prefix. Okay, if any means if it is added before primary prefix, if it is present. Okay, if primary prefix is present, then before that primary prefix. If primary prefix is absent, then directly before word root we will put it. Okay, or root word if primary prefix absent. Got it? Suppose this is the name, okay, CS3, CH2, CH, OH, CH2, CH2, CO, OH. Now you have to numbering 1, 2, 3, 4, 5, 6. Now you just see there are two functional group. One is carboxylic acid, another one is alcohol. So for this, what we'll do, this will be your secondary suffix, and this functional group will now come on secondary prefix. How you are going to name this? What is the word root? 6 carbon. So hex. All are carbon carbon single bond. So hexane. And then E I am dropping. This is the secondary suffix is your carboxylic acid. So oic acid. So hexanoic acid. Now we'll go to primary prefix. We don't have any primary prefix because the compound is not cyclic. So directly we'll write the secondary suffix prefix. Okay. So it is with the position I'll write 4 hydroxy hexanoic acid. Got it? So here, if it is writing in secondary prefix, it won't be OL, it will be hydroxy. Okay, so 4 hydroxy hexanoic acid. So by this, I have just completed your word root name, like whatever the formula it is given, that I have completed. But now you have to see the rules for nomenclature, okay? The rules for nomenclature. Rules for nomenclature. These rules you have to follow, okay? Rules for nomenclature. So first part, I'll take your substitute, okay? Whenever the substituted alkanes are present. Okay, substituted alkanes. First, we'll see in the substituted alkanes, we have to find the longest chain. Okay, so first will be your selection of the longest chain. Correct? First rule will be your selection of longest chain. Okay, how you are going to select the longest chain? See, if this is the example, CS3, I hope you know this, CH, CS3, CH2, CS3. Got it? So in this, how you are going to select the longest chain? See, 1, 2, 3, 4. 1, 2, 3, 4, 5. So if we are going, I will just change the color so it will be easy for you. There will be two types. One is like if I'm going with this way, but what are the number for parent like longest chain? How many carbon will be there? Because the longest chain will decide the word root. Okay, so here 1, 2, 3, and 4. So if you are selecting this is as a longest chain, then your word root will be but. See 1, 2, 3, then 4, and then 5. If you are selecting this is your longest chain, if you are selecting this is your longest chain, so you have to work it out and you have to see which one is your longest chain. If you are selecting this is your longest chain, then your word root will be pent. Here it will be but. So you have to select. Okay, always select the longest chain, not the least one. Always select the longest one. Where the carbon number is more, that part you have to select. Okay, so here the longest chain will be your 5 carbon. Okay. Then now one more example I'll take CH3, CH2, CH, CH3, CH2, CH2, CH3. Now in this case again, this is your 4 carbon member and below one is your, we are going with this. See, it is not completing over here. It is like continue like this. So now how many carbon are there? 1, 2, 3, 4, 5, 6. So if this side you are going, it will be but. If this side you are going, it will be hex. So the longest chain will be this. Here the longest chain will be this. Like that you have to select it. But now we are not selecting the substituent. That we will go further. Okay, this is the rule number 1. Only selection of the longest chain. So this in this rule we will know only this much. Okay, selection the longest chain. Now the selecting the parent chain. Now we have to select the parent chain. Correct. Second will be your selecting the parent chain. And based on parent chain, we will continue the name. Will after selecting parent chain, we'll start numbering. Correct. So the most, here we have to write the most substituted, or we can write the more substituents one is the parent chain. Correct. Suppose this is the example CH3, CH, CH, CH2, CH3. Here one bond is there CH3. Here CH, CH3. Down also CH3. So now we know that if we are counting over here, I'll just change the color. 1, 2, 3, 4, 5. If this is the longest chain we are selecting, then 5 carbon is there. Is there any more way to select? 1, 2, 3, 4, 5. Okay, here also it is 5. 1, 2, 3, 4, 5. Here also it is 5. So now which one you are going to select? Whether this is your longest chain. Longest chain will be 5 carbon. That is already fixed based on the selection rule. Okay, selection of the longest chain. Now we have to find which one will be the parent chain. Whether okay, I'll draw the line. Whether this is your parent chain or this is your parent chain that we have to select. Okay, now if we are moving from this side, we have to see the most substituents one is the parent chain. So now if this is the parent chain we are selecting, what is happening? There will be one substituent and this will be your whole substituent. So there will be two substituents. If we are selecting this is the longest chain, okay, parent chain, then we have two substituents. If we are selecting this is the longest or parent chain, if we are selecting, because both are having 5 carbon, so if we are choosing this one as a parent chain, so how many substituents we are getting? This will be 1. Okay, going down, this entire thing will be 2, and we are moving this side, so this will be your 3. So if we are taking this is as a parent chain, so we are getting 3 substituent. Okay, so the more number of substituents, that will be the parent chain. So now our parent chain will be this. So here while numbering we have to see, okay, in this case 3 substituents are there, so this will be your parent chain, and in the third rule you will see the numbering, how you are doing numbering. So here it will be 1 2 3, here also 1 2 3, all positions are in the same position whether you are counting from this side or that side. So it will be like total 5 carbon is there, so it will be pentane. But before pentane you have to write this is ethyl and this is methyl, so it will be 1 2 3, 3 ethyl, 2 4 dimethyl pentane, correct? So I hope you understand this selecting the parent chain, correct? Now the next we will take it your uh, numbering of carbon atoms, okay, because already we have select the parent chain. So next one will be your numbering of carbon atoms, okay, in the parent chain, because you have to select the parent chain. First you have to select the longest chain, then you have to select parent chain, and after selecting parent chain you have to give numbering. Okay, without numbering how you are going to write the substituents where it is present? Okay, so just write numbering starts from the end which has a nearest substituent. It means from which side we have to start the numbering? The numbering will start like whichever side the substituents will come first, right? So it will be CH3, here it is CH, it is CH2, and then we have CH3. So in this case, I'm just giving this as an example. Now you just tell me there will be two way of numbering. One will be 1, 2, 3, 4. See, first we have to select the longest chain. So longest chain will be 4 carbon only. Either you are counting from this side or you are counting from this side. It will be 4 carbon. Then parent chain. See, either you take this one as a parent chain or you take this one as a parent chain. You will get only one substituent. Okay, only one substituent. So two rule is already bypassing. Now then we have to go for the third rule. So according to third rule, this is the one way of numbering. And what can be the other way of numbering? So this is your 1, 2, 3, and 4. See, we can number it both the side. This will be B numbering. Okay, just we have to name it. Then only we will come to that which type of numbering, which side numbering is correct. So if I'll name this side of numbering is A, then I will name it this side numbering is B. Now we have to see and which side of numbering we are getting first substituents. Suppose numbering A, the first substituents is coming, just repeat it 1, 2. In second position only we are getting the substituents. So we'll just write second position. While numbering B will start 1, 2, 3. So where the first substituents is coming or branch, it is on third carbon. So we'll just write third. Now you just see numbering starts from the end which has a nearest substituents. Now see, if I'm numbering from side A, we are getting substituents on second position. If we are numbering from side B, we are getting substituents on third position. So which way we are going, like which one will be the correct way? According to this rule, the numbering from which end it is coming nearest, right? So it will be your second position. So the numbering A is correct here, not the B. Okay, so through numbering A, what will be the name for this compound? It will be your bute. Okay, but branch is there, so we have to give some space over here. So word root is bute all are single bond, A and E. Now you just see second position you have methyl. So 2-methyl butane, correct? Now if you are wrongly doing numbering from this side, what will happen? It will be 3-methyl butane. Okay, see both name is different, 3-methyl butane and 2-methyl butane. So 3-methyl butane, if you are numbering with this B side, so it will be named 3-methyl butane, and you know that is wrong. Okay, this is wrong, 3-methyl butane, because according to rule, this is only the possible way, because the substituents is present in the list number, like the numbering second only it is coming, like nearest it is coming, so we have to numbering through this. Okay, numbering A, numbering side A, not the numbering side B. So now the fourth rule we will see. Fourth rule, it will be numbering of carbon atoms in the parent chain. It is same number, same type of rule, but little bit changing is there. Okay, numbering of carbon atoms. Okay, this is not required. Okay, numbering the substituents. Okay, numbering the substituents present at, this is very equivalent, very important. Okay, equivalent position in the parent chain, correct? So how we are going to give this numbering? In alphabetical order. Okay, in alphabetical order. And when we follow this alphabetical order, see if the substituents present at equivalent position. If it is in other way, like one is present in second, this side if it is present in third, then we are not going to do with this alphabetical order numbering. But name, definitely name we are going to write alphabetically only, correct? So we'll discuss couple of examples, then only you will understand. First, just try to understand this example, okay, how we are numbering this. Suppose this is the example, CH3, CH2, CH, CH2, CH, CH2, CH3. Correct? Here I am just putting methyl. Here I am putting ethyl. CH2, CH3. Now you see, this is the numbering side A. 1, 2, 3, 4, 5, 6, 7. Correct? And this is the numbering side B. 1, 2, 3, 4, 5, 6, 7. See, first of all, based on rule number 1, we have selected the longest chain. This is a 7-member. Then we have select the parent chain, the number of branches where it is coming maximum. So here 2, whichever way you just calculate, it will come under 2 only. If you are giving like this 1, 2, 3, 4, 5, 6, 7, then only see 1 and 1. 2 substituents are coming. If you are selecting this as a longest chain, parent chain, then also 1 and 1, 2 parent chain it is coming, right? So 2 substituents it is coming. So the parent chain can be anyone, either from this side or this side. So I have taken the straight line to discuss this numbering way, whether it is from A side or from B side. Okay. So now you just see, if I am numbering from this side, 1, 2, third. So first substituents is coming on third, correct? And if I am numbering from B side, 1, 2, 3. So B side also it is coming on third. So now position is same, right? But here in the third rule, we have seen that from whichever side the substituents will come first, we will take that numbering as a correct numbering. So we have selected this second one, right? This 8 numbering we have selected because first substituents came on second. But in this case, what is happening? If we are numbering through A, we are getting on third. If we are numbering through B, we are getting on third. Now next, if the position, see, if the position is same, then only you have to go for alphabetical order. If the position is same, then only you have to go for alphabetical order, or else no. See, now position is same. So this group is starting with M, methyl. This group is starting with E, ethyl. So in alphabetically, E will come first, then M, right? So numbering will start from A side because alphabetically E is coming first. Here in this B, M is coming first. So the numbering side, this will be your correct order. Okay, so it will be your 3 ethyl, 5 methyl heptane. This name will be 3 ethyl, 5 methyl heptane. correct? So this is the fourth rule. What about fifth rule? Fifth rule says the lowest sum rule. Okay, so what is lowest sum rule? We'll take the example and we'll see. We'll add up, we'll sum all the position, all the branch position, and then we'll see where the lowest number is coming. Through that way, we'll give the numbering, correct? CH and then CS3. Okay, and then CH, here it will be CS3, here it will be CS3, here it will be CS3. Now see, rule number one, we are selecting the longest chain. Rule number two, we are selecting the parent chain based on the substituents. Rule number three, we have to numbering it. So just try to numbering it. So this is the numbering side A, 1, 2, 3, 4, 5 and 6. And this is the numbering type B, 1, 2, 3, 4, 5 and 6. Okay, so now you just tell me which numbering will be correct. So whichever way, according to rule number 3, whichever way the first substituents will come, we'll take that numbering. So see, start with, just I'm write A. Starting with A, the first substituent is coming over second. Okay, now from start with B, first substitution is coming on second. So we know that if the position is same, then we'll go for rule number 4, which is says that if the position is same, then we'll go for alphabetically, correct? Now you just go. Here, this is methyl group, it will start with M. Here also it is methyl group, it is starting with M, correct? Now both the side it is starting with M. So that also not utilizing. So that's why rule number 5 it came. Write all the position and add up. Okay. Now from A side, first position is coming on, like first substituent is coming on second, second substituent is coming on third, and third substituent is coming on position 5. Just add it. 2, 3, 5, 5, 10. Now here you add it. First substitution is coming on position second. Second substitution is coming on position fourth, and your third substitution is coming on position fifth. So how much it is coming? 2, 4, 6 and 5. It is 11. Now which one is the lowest? So that's why lowest sum rule. Just add it. Okay, after summation, which one is lowest? This one is lowest. So that numbering A will work over here. Correct? Numbering A will work over here, not the numbering B. Got it? So these are the 5 rules to name. Okay, to select the parent chain, select the longest chain, then to select parent chain, then to start numbering, then alphabetically order, then your lowest sum rule. Okay, these are the rules. Now second will be your, that is the alkane we have taken, right? So here it will be, we are now adding alkene, means we are adding all, whatever we have discussed, those are all single bond. Now we are adding alkene, alkyne and substituents together we are taking. First we have taken only alkane with substituents. Now we are taking alkene, alkyne and substituents together we are taking, correct? So we'll continue this class. Okay. So till this whatever I have taught now, you just do revise and you write it in your notebook. This will be very much helpful. And going forward, before your examination, I'll complete your syllabus. And that also in free of cost. Okay. Likewise for fourth semester, I will, whenever I'll get the syllabus, your fourth semester also I will try to prepare. And don't worry about the first semester student and second semester student. I'm going to prepare for them also. Correct? So whatever SKMU is having syllabus, SKMU, I'll just cover it for UG first. Okay, based on NEP. And then I will move, once the UG part will complete, I will slowly move towards MSc. Okay, there also I'll give in lecture for entire syllabus. Correct? So if you like, please do subscribe and share to your friend. Okay, they also need this, right? So thank you for watching.